Okay, so the first part is going to go ahead and be an amplitude. And what I'm going to do is that I'm going to put the sine in its parent form on the graph just to show how the amplitude changes the graph itself. So let's put the sine graph on. There we go. And I'm going to just basically, and the reason why the larger dots are there is that when you sketch out a sine graph, it's really pretty easy if you just look at the peak, which is right here, a valley, which is right here, and of course the x-intercepts. And I'm just going to do this over one period because it can go on forever, and that would be unnecessarily long. Okay? At any rate, and so when we start shifting stuff around and putting things together, we have this form off to the right here. And to find the amplitude and what it is going to do, you take the absolute value of A. So for example, if I wanted to see what this graph is going to look like, for the amplitude, we would just take the absolute value of 2, which is going to be 2. Now, here's the deal, is that the easiest way to do this out is just to adjust the peaks and valleys. So, because the period is not changing at all. We're not changing the length of this graph whatsoever, but the period starts off as 1 right here, as you saw in the last video. So we want to make it 2, so we're just doubling that. And this is also 1, even though it's a negative going in that direction, it is going to double and be down here. And so the zeros, or the x-intercepts, are just going to stay the same, and then we trace through it like this, and that is how we adjust the amplitude on that guy. Okay, so looks kind of like a cool, I don't know, space age thing. At any rate, the amplitude for this guy right here is going to be a negative, and it is going to be half. Okay, so the amplitude itself is going to be a distance, all right, but we still got to take, in fact, the negative is going to flip the sign around the x-axis. So the amplitude still is going to be a half because it's a distance. However, what we're looking at is that we keep all these points the same, okay, the x-intercepts. However, I go to the original blue graph, okay, which is going to be the parent sine function, and I want to make the amplitude 1/2, but I also need to flip these over the x-axis like so, okay? So again, this starts off as 1, and now it has to reflect and go a half, all right? So we do that to the peaks and valleys, if you will, and this is what, and that guy again, 1, flips back up here, and so we end up with kind of a, kind of like a smaller version of the graph, if you will. So looks like that. And so that's how we deal with the amplitude. And we usually do that out first when we're graphing something that has a lot of moving parts. So anyhow, that's how you do that. And then let's go on to the period and how to change that and graph it.